Hello everyone, welcome you back. Today we will cover Spring JPA. If we want to fully cover this topic, I will cover Hibernate ORM and Hibernate JPA and then Spring JPA. But now Hibernate JPA is like a legacy system, and in our future, we will basically use the AWS, Amazon Web Service, with DynamoDB instead of a relational database. So we will just give a brief introduction of the Spring JPA, the more latest version of JPA. So before that, let me give you a brief introduction of the database. Okay. Database, there are three types of database. The first one is called the relational database. So the typical relational database is like Oracle, SQL Server, MySQL, DB2, and so on. Okay. These kind of database, they are traditional database with two-dimensional tables. Okay. So we have rows and columns, and we have table schema. There's a concept like a primary key and foreign key, and those concepts. And then they build relations between different tables. They may have one-to-many, or one-to-one, or many-to-many relationship of those tables. So there's a language called SQL. SQL is a sequential query language to handle or search for data. So we have there are four things like CRUD, like create, read, update, and delete data. Okay, so there are one reading operation and three writing operation like update, delete, and save. Okay. So this is traditional database. So I strongly suggest you to go through the SQL tutorial if you don't know SQL in W3 school. Okay. So in this tutorial, you can go through what is SQL and what's the different query syntax of the query to search for data. So there are lots of examples you can try it yourself. You can go to this website to go through SQL. But if you already know SQL, SQL is a very pretty easy language and very straightforward. If you already know it, then we can go ahead. I assume you should already know some SQL. Okay. Now that's the first type of database. The second one is a famous one like NoSQL database. A typical one is MongoDB. So this is based on a document with JavaScript, with JSON format data. JSON, the full name is JavaScript object notation. JSON is very simple. You can also search what is JSON. So JSON is very important. In our REST API, we just communicate with data or in JSON format, or in string or JSON format. Okay. So there's MongoDB. MongoDB, like in some full stack applications, they might use the Node.js, AngularJS as a front end, and Node.js. Then the back end is MongoDB, something like MEAN, right? MongoDB, AngularJS. E is Express, right? N is Node.js. So that's a different style of application. So we won't cover MongoDB. And the third one is based on key value pairs. Key value pairs DB. The latest typical one is DynamoDB in Amazon Web Service. So we will cover DynamoDB in our AWS course. So this is a brief introduction of the database. Now let's go back to ORM. What is ORM? So because in Java is object oriented, right? In DB is relational. So they should have a mapping. We cannot communicate directly. It's not in the same format. So for example, if in database we have a table called person, the person has ID name, age, and so on. Right? So there are lots of fields, lots of columns of the table, and in the class, I may define a person entity with PID, with PName, and age, and so on. Right? I have my own field. So I need to do a mapping, like I have to map person entity, map to person table. I have map PID to ID, or PName, map to name. And then I have age, map to age. So that is the class name is mapped to the table name. The field name is mapped to the column name. So in conventional setting, we usually use the same field name as the column name. So if the column is ID, then my field name is also ID. I don't use different. Otherwise, I have to specify what kind of field, what kind of column you want to map. This is kind of OR mapping. So in the query, so you can have SQL, and we also have the SQL will be mapped with SQL. Okay. So in the SQL, we select from a table name and where some column equals or bigger than or something, some value. And in the SQL, or say Hibernate query language, and then we also select from an entity, from the class name. Then where the field equal to something. That is ORM. Now, if you want to go through very detailed into the deep part, I suggest you to go to my Bitbucket repository. This one you can call this one. It will cover from the simple OR mapping to like one-to-many, many-to-one, one-to-one, many-to-many, all those examples. So it has different types of mappings with those things, and with different branches. The branches from Hibernate 01 to Hibernate 10. So let me show you this one. I can duplicate this one. That's my old as a practice from this one. If you go to this Hibernate, so you can have different branch from Hibernate 01 to Hibernate 10. So it has order from the source code, from the mapping, so you can have everything here. But if you have interest, you can go deep inside. And if you have, in the future, if you work with OR mapping in your project in industry, so if you don't know how to do the one-to-many mapping or one-to-one mapping or those mappings, you can go through the code to know how to do the mappings. Right. So this is about this repository. Now we will use Spring JPA for our example. Let's make a test. Let's make some hands-on. So now I new with Maven project. So now I give a name, say Spring-JPA. And this one I can use as a DB. The group ID is DB. And I finish. So I will copy this poem and add something else. Okay. This is the poem. So I just change the group ID. Group ID with DB, and this is JPA. Okay. His name is demo of Spring JPA. Okay. And I use those things. Now this one I use starter JPA. Okay. And I think I also need a database. We can install a database like Oracle or MySQL, but I prefer to, because I don't want to set up another environment for you. So if you want to set up your MySQL or Oracle, that's fine. That's fine. That's completely fine. But as a training purpose, I just use the embedded database. That's an advantage of Spring Framework or Spring Boot. So it has an embedded database called H2. H2 is a very basic one. So I can find the dependency of H2. Okay, this is JPA, this is test, this is H2 here. I need this dependency. JUnit. Then after that, I add H2. So okay. That's artifact. What's wrong with that? It's like this JPA. Let me see what's the dependency for JPA. Oh, data JPA. Okay, sorry. So this one. It's not directly JPA. It's data JPA. Or sometimes it's called Spring Data. Okay, let's update this one. Okay. Now let's do the same thing. So we do Maven update. What's the update? Okay, to remove this red cross. Okay. Now this is the so this is a POM. Now we create a package. So in the database side, we usually have two packages. One is called entity. Entity is to define a Java class which is mapped to the table. So the second one, so this one I can remove it. In the test, I can remove it. Package DAO. DAO is a design pattern. What is DAO? DAO is called data access object. So this object, we define this object is to interact with the database. This could be related, interact with the relational database like Oracle, H2, or it can be interacted with MongoDB, or it can be interacted with the DynamoDB. So it needs an interface, and then we could have some implementations. Okay. Then next is a config file. So we always need a config file. Config. Okay. Now, first let's do the entity. Let's do a simple one. So here, I cannot remember all the code, so I just start from this code. Let's say we have a main, this one with entity. So we have an employee entity. Let's define this entity. Then let me explain. New class employee entity. So now I copy all the code. Okay, the package don't need it. Okay, now let's talk about this is a typical OR mapping. The employee table, employee entity is very simple. First, we have employee, we have ID, we have name, we have salary. So we have a column, we have at column annotation, which means that it maps to a column. And we have at ID means this ID is a primary key. Now for the two lines, I will explain later, so I can toggle comment. I can just skip this one. I just say ID is the primary key, and this is a field. So if you give a different, if you say PID, if you want to give a name, so you can say the column map to some other ID, right? So if the column name is PID, then you can say name is this. But now I use the naming convention, so my field name is matching the column name. Okay, this is getter and setter, so nothing else. Now on the top side, we define two annotations. The first one is called at entity. The second is a table. The first at entity means this is an entity. This is an entity class. The second table is mapped to a table. The table name is employee. So I intensively give a different name. This is employee and this is employee entity. We use entity to represent an OR mapping entity class, which is mapped to a table. Okay, so this is a is different. This is employee. This is employee entity. Okay, this is one thing. Okay, and the two lines is how to generate the ID. So you can give a fixed ID, like ID is 100, 200, that's fine. Or you can automatically use the sequence to generate the ID. So this is to create a sequence. That's a different story. So this mapping is very straightforward, right? So there's nothing else. Now, next, let's talk about DAO. This is DAO. So we have an employee DAO. This I use interface. Okay, then I copy all the code. And I will explain the code one by one. Okay. Now, so this is employee DAO. We don't have a concrete class to implement the employee DAO. I just give an interface. So it's kind of weird because in the traditional Hibernate JPA, you have an interface, then I have the implementation of the interface, and I will go to the details of the method. But through Data JPA, they provide very convenient interface like the JPA repository. You can extend the JPA repository with your entity class and with your ID. So the first variable is the class of the entity class. Is the entity child class. The second one is the primary key. Is a primary key. Our ID is a integer. So this is integer. So this is JPA repository. Now, I write those things. The JPA repository itself provides some method like get by ID or something. So I will talk about later. This is the employee DAO. The next is important is the config file. So as we mentioned in the previous class, Spring Basic, we always need a config file. So then let's do the class. Say dbconfig. Dbconfig. No. dbconfig. Okay. In the DB config, we need to clarify something. The first thing is we have to enable JPA repositories with the base package. So the repository is under this package com.bval.db.db.dao. So this is one important thing. If without this one, this DAO will not work. So you can see this DAO, we don't have to add a component or repository here. So with the with this enable JPA repository, the system will go to this package to find all the sub-interfaces of JPA repository and create the object for it. This object is not to create object of the interface, it's create some subclass. That's we say anonymous inner class of the subclass for the interface. They will do the implementation automatically, so you don't have to worry about that part. Entity scan is that where do you find the entities? You need to specify where do you find the entities. So based on those entities, it will show you, okay, this is the OR mapping. So you need to find all the entities. The third one is component scan. So this component scan is to automatically create object of those stereotypes. Okay, we already mentioned this before. So inside we don't have to do anything. This is empty one. We just have the three annotations. That's good enough. Now, next, we need to import the 4 parameters of the database. Last time we talked about database has 3 parameters, 4 parameters is URL, driver, username, password, right? So we need to define it in the resource file, in the application.yaml, and then a new folder resources. Also in the test, I can also write resources. Resources. No. Under resources, I can define file application.yaml. Now let's talk about the application.yaml. Okay. So it's here. This one. Okay. Now let's copy. This YAML. So in this one, we have Spring data source and the JPA. So the first is the 4 parameters. Then this JPA, here you be careful about this happiness.ddl auto. So because we don't have a table yet, we only have the embedded database H2. So with this create, auto equal to create, it will automatically create the table for you. Then this is direct. Direct will be compatible with SQLs. And format SQL equals true. So if you want to with some logs with SQL, they will print out some SQL language. So do you need a format or no format? Okay, so we can format it and we can show SQL. If you say this is false, and then it will not show SQL. If this is false, then the SQL will be only in one line. Only in one line. This is logging level. This is logging level. Logging level is only error it's print out. Otherwise, it's not print out. And this is I can add a db debug. Okay. Now this one. So there are two parts. One is log part. One is Spring config. Spring config. Now let's make a test. Now, and the test new package. We only test the DAO. New class employee DAO test. Okay. To make those resources look better, so last time we mentioned we can delete it and re-import it. Okay, so this is the application YAML. In the test, let's do the test. So in the test, we have Spring Boot test. So I don't want to run it. So let's so first I need to add those the first three things. So in the test, I use Spring Boot test. That's what we already have before. db config. So I have extensive. Sometimes we need it, sometimes we don't need it, but in the JPA we need that. And enable auto configuration and exclude this configuration. So this one you just need to know, you need to add it, and I don't want to go to details, so we just copy the code. Now let's make a test. So we can auto while the employee dot em dot here. I just make simple. I just make just say dot because this won't be confused in this class in this test. Now, first test. Okay. Before that, I need to save some records inside the employee because now we have an empty table, right? So let's say I test this assertion start assert not now. So it really has a DAO here. then that's not. So I just run this code to make sure this DAO is already created based on this configuration. Now let's see what happens in our console. Okay. In our console, you can see using direct, so these things are already there. So the Hibernate is a job table, employee if it exists, then it will create a table. So because there's an entity scan will find this entity, but they cannot find this table. They will automatically create a table for you. The reason is, so it's good. The reason is we have entity class, but we don't have an employee table. Okay. So in this config, in this config, it will have DDL auto will have a create. It means it automatically create it for you, create all the data for you. Sorry, not all the data, create the table schema for you. But this table is an empty table. It's totally empty table. We cannot find anything. Okay. Now, next. So how do we initialize data? So in the employee in the test, of course we can use some method to like save. Like we can say dot save some object. So we don't define this save. So this save is inherited from the JPA repository. That's the top level. See, JPA repository. JPA itself contains some method like save and find by ID, those things. Okay. Now we can save a records and then we can start testing. But this is not convenient. A good way is we write the SQL for the system, and the system will automatically call those SQL. So it will recognize two naming conventions. One is called let's remove this one. One is called schema.sql, and another is called data.sql. Schema.sql means that it will create a table, create sequence, create any table schema or sequence schema, and the data SQL is will insert some initial data. Okay, so I will copy. I will do this for the test part. I can move to the test resources, or I can also move into the main resources. Now I use the test resources. New other, and then in this option you can find there's a SQL here. Let's see, yeah, SQL derived SQL file. The first SQL is schema. So this is the schema. So let's go to the schema.sql. Okay, I will run this schema. I create the employee if it exists, and then I will job this table if it exists. Then I create table employee with ID, name, and salary. Okay. So the three fields. So the ID is primary key, and then I create sequence. I will talk about sequence later. Okay. Now this is one thing. The second one is I will create new other SQL. This is data.sql. So we'll insert some data. Okay. Let me insert three as four data. Okay. Let's just insert four data. So with Alice, Bob, Jason, James. So with 100 starting from 100, 101, 102, and so on. Okay. Now, but that's not enough because if we have this auto, it will automatically create table. It will not go to this data and schema. So we have to change this. Create to none. I don't want it to automatically create a table for me. I want it to use my schema dot SQL and data.SQL to create the schema, to create table, and insert data for me. So I need to override this configuration. So I will create another one. It's just a general file. I will create application-test.yaml. In this YAML, I only need this one, JPA repository. So in this one is Spring, and then I can override this feature. So let's see. I make it as a none. With this kind of thing, then I can go back. I can go back to my test. In my test, I need to add active profiles test. Last time we mentioned about this. For testing purpose, I give initial data. So now I can test find by ID. Let's see. Equals to dot find by ID 100. Okay. Now here I need to explain the optional. Optional is an API, is a class introduced in I think it's Java 8. It's also a Java 8 feature. So if you say what's the new feature in Java 8, I think lambda function stream is a very important feature. Optional is another one, and a switch is another one. Switch can switch a string, not only the integers. Okay, now what is optional? The old version of the DAO, if you go to the JPA, Spring Data JPA for the previous one, like Spring 1 or 2.0 or something, so it will print, return the employee entity directly. But if the ID does not exist, it will return null, right? So if you operate on this employee ID, say get the name or get salary, it will have null pointer exception. To prevent this, they have optional. They will first ask if optional contains data or not. So optional is a wrapper of object just to prevent the null pointer exception. Personally, I don't think it's that much useful. But anyway, okay, they have optional. So let's make a comparison. So without this test, it means that it will read the empty table without using my data.SQL to insert data. So in this way, I will assert assertions. Oh, just assert false of op dot is present. The is present method will return if this data exists or not. Okay, so definitely if you use the default setting or use this application with create, then this ID, this 100 does not get any data. Okay, wrong. Let's run the test. See, now you can see create this table, and I use select this is Hibernate query. I use create this table. This is empty table. Then I select these things, so it doesn't return any data. So it means that this optional contains nothing. Okay. Now, if I use active profile test, okay, which means they use DDL auto is none. So in this case, it will use the data.SQL and schema.SQL to create the table, and it will contain data. So this 100 will be added, right? So let's make a test. This should be true. Then I can go ahead, employee entity equal to empty dot get. We get data, and then that equals Alice entity dot get name. Okay. Let's see what's the salary. 72, this one. Get salary. Okay. So now let's see the queries. Okay. So internally it will define this. It doesn't show the query, but it will select the correct data. So the unit test is correct. So it really gets the data with the value ID equal to 100. Right. So this find by ID is the method provided by JPA repository. Find by ID is defined in JPA repository. It's not defined by us. Now let's make a test of our method. Okay. Now go to I already explained the application dash test. Now go to this doc. Now let's go one by one. The first one is find by name. Name is not ID, so this one is not defined in JPA repository. You need to find by some field, based on some field, find by name. So this is a naming convention. Find by this method cannot be anything else. So you have to say find by a field name. Okay, that's the naming convention. So it's find by, this is the field name. So based on this naming convention, then it will automatically generate the query for you. Then the input is a name. So let's think about this one. Test find by name. Okay. Now, let's say find by name with Bob. I think this one will return the will not return optional. Will return this directly. Entity. So in our query, the Bob has this value. So we will add two things. First, I will check his ID is 101. The salary will be this. So I don't have to check the name because I already find by name. Okay, check this. Okay, then it's working. It's working. Now, so this is the first style of this interface. So if you use the naming convention like find by something, or you can find by multiple fields, you can say find by, you can use this naming convention, find by field name 1, then and field name 2. Then you can find run a query to find for both name matches, or you can use all. Okay. So there are a list of naming convention. I don't want to go too deep that here. You can go to document to find out how to use a naming convention so that you don't have to write any code. You don't have to write any code. Just use naming convention. You can easily get some data. Now the second way, I want to find the salary between the minimum salary and the maximum salary. Okay. So in this way, you can see select E from this one where this between this. So this one, I think there could be a naming convention, but if you want to make things easy, because that naming convention will be very long. Okay, something found by something between something and something. It could be. I'm not sure, but you can use a different way. That is, you use @query annotation to teach the system how to query. So you can see select E from employee entity. This is a HQL, not SQL. And so this is from the class, not from the table. E is the alias or is the object. In SQL, this is alias, but in object-oriented, this is object. So the salary between this column is the input parameter. This column is the input parameter. So I want to find all the employees between two kind of salaries. So let's make a test of this one. Test find by salary. Now the result will be a list of employees. Let's say entities equals to dot find by salary. Let's see the minimum and the maximum salary. Let's say the minimum salary, let's say, is 5,000 to 8,000. Let's say 5,000 to 8,000. 50,000 and 80,000. Okay. And then we only have two records, 101 and 102, right? So Bob and Jason, they are, Bob and Alice, their salary is between 50,000 and 80,000. So this is bigger, this is smaller. So I only need to assert the size, size. Okay. Okay. Then it will work. Okay. There are only two records. Their salary is between the two values. Now, in this style, we have the second style. The first style is naming convention. Actually, there are four different styles. The first style is directly from JPA repository, like find by ID. The second style is I use naming convention. I don't need to write any query. So the system will build a query for me, use a find by or some naming convention. You can go to the document to find the details. The third style is that you want to use your customized query, you use add query annotation, then that's the third style. Okay. Now the fourth style is to do the writing. How do I update? So I want to update salary. So also you have the query. I update salary with a name. Okay, update this one. Set salary is the plus the increased salary where either name equal to name. So this is increased salary. Okay. So this is increased salary. So then we have to use modify. Means that is we have two annotations. One is called modify. One is called transactional. So these two annotations is very important. Otherwise, this transaction will not be committed. Now let's make a test. I want to update Jason's salary increase 1,000. So his salary will be 84,000. Let's make this test. Is update salary by name. The return value is how many records are updated. It may update one record or update multiple records. Okay. Now let's make a test. Let's say int count is equal to dot update salary by name. The name is Jason. The increase salary is 1,000. I just increase $1,000, and then that equals 1 count. So only one record is updated. Then I get this employee by name. Entity equals to dot find by name Jason, and the salary will be 84,000. Let's make this test. Okay, so you can see the query update the employee salary equal to salary, right? Then I use select. Right? Now I need to test about this, about modifying and transactional. For example, if I don't have transactional, what happens? See, you can see invalid access API usage executing an update needs this one executing an update delete query, right? And there's an exception. So because you need to make it as a transaction, If without transaction, it's not a transaction. Okay. So in the console, it's not displayed in the console, but it's in the unit. Invalid access API usage exception. So it means that if you want to do some writing process, reading doesn't matter. You don't have to use transactional, but writing is update. You have to use transactional. What if I comment this modify? What happens? Okay, see the same thing, right? The same thing happens. So it means that if you want to update or save or you run some writing queries, you have to add two annotations. One is modify, one is transactional. That's very important. That's very important. Now, the last thing I think I will go back to my entity. I want to explain the two. I want to explain the two things. Right. So this is to how to generate this ID. It's not hard-coded ID. So in our query, you can see we hard-coded 100 those things, right? But we can also use sequence to do that. Okay. If we want to use sequence, how to do that? So you can see in this schema, there's a sequence start with 100 and increase by 1. So if I use this one, this entity. So the generated value is the strategy is use sequence. The generator is EMPID generator. Then the generator part. This generator corresponds to the sequence name is employee sequence, right? Is this employee sequence? Okay. It means you sequence generate data, and there are other ways like you can always make it increment or something. So then the schema is increment by 1, so it will get the maximum value of the ID and increase by 1 by the sequence. So let's use another one, right? So maybe I use 1000 to make things easy. Yeah. Now I want to save a data. Test word save. Test save. Now I create employee entity equals to new. So in this entity, I don't set any ID. I just set name. Just set name equals to Alex. Dot set salary. I can use any salary. Now, then I use DAO to save the entity. Then I just get another entity. Say result equals to dot find by name at Alex. Because I don't know ID, so I can print out the result ID. I want to see what's the ID. Result.get ID. Okay. I don't use assert because this ID is automatically generated by the system using the sequence. Let's run this one. Okay, the ID is 1000. You see, that's 1000. So you can see, then you will call next value of this sequence, right? Because you use sequence, then insert into this table, and then the ID is 1000. So this is an easier way that we don't have to manually create ID, and we automatically generate ID use sequence. That's widely used in industry. I think this is pretty much for the Spring JPA. And next class I will talk about the Spring REST, and we will use Spring JPA as the backend as a data provider. Right. I think that's all for JPA. Thank you.